Hello, you guys. All right, so I found out about this extension on Google, and it's called Screen Classify, and I wanted to try it out. So I have this, excuse me, I told you guys I'm getting sick. I have this IKEA plant, and I'm going to use it for my demonstration. And then I also have these cones that some of you guys use when you are practicing on your speed with track and even soccer. All right, so today's lesson focuses on finding the volume of truncated cones, and that's basically a chopped and screwed, broken up cone. So I wasn't able to find an actual cone, so I'm going to make a cone. I have this IKEA plant, and I wasn't able to take the flowers out of it, so I'm just going to flip it over, and I want us to all use our imagination. We are going to pretend that this cone fits right on top of there, and we're going to act like the bottom doesn't even exist. All right? So as we have this cone, I want to know what is the volume of this portion right here. So we are going to pretend that this orange cone is glued onto this black part. And I want to know what is the volume of this part. We all know how to find the volume of a cone. What is it? Pi, well, 1/3 pi r squared h. So the volume of a cone is 1/3 pi r squared h. So I want to find the volume of this part. How do I do it? Good question. I'm glad you asked. So I have this larger cone, and then I am going to say that I have a cone within a cone. So this is the larger cone, and then this is going to be the smaller cone right there. So from here to here, that's one large cone. And then from here to here, that's the smaller cone. So once I know the volume of the larger cone, if I subtract the volume of this part, I'm left with the volume of that, right? Okay, so this is how you do it. You have to find the volume of the larger cone, but you can only do it if the two triangles are proportional. So you want to use your AA criterion that we learned way back in Module 2 to determine if the triangles are proportional. So you would do your image over your pre-image for two sides to get a constant scale factor. That'll be the first part, making sure you have a constant scale factor. And then the second part is making sure you have congruent angles. So we already know that there's 90 degrees in a right angle. So if I'm telling you that this is a right triangle, then I know that I'm going to have a right angle right here. And then for the smaller one, I'm going to have a right angle right there. So I have two right angles, and then I have proportional sides. So boom, I have I have proportional triangles with a constant scale factor. So what you are going to do is you're going to use your formula to find the volume of the whole entire triangle, and then it's the cone. Oh, I keep saying triangle, but it's a cone, but triangle. And then you are going to find the volume of this smaller portion, and then you are going to subtract the smaller portion from the whole entire volume, and then you are left with just this part. So those are the instructions. Let's try it out.